What up, Algebra 2? This is Mr. Hotard. This lesson is on expanding binomials using something called the Binomial Theorem. So we're going to start with some easy problems. Now these are called binomials because they have two terms. So if you have x plus 1 to the 1 power, that's easy. That's just anything the 1 power is itself. That's just x plus 1. Now, x plus 1 squared. This does not mean x squared plus 1 squared. What does this squared mean? It means you're multiplying it times itself. You're doing x plus 1 times x plus 1. All right, so when I work that out, that will give me x squared plus 1x plus another 1x plus 1 times 1 is going to give me 1. So that's going to come out to equal x squared plus 2x plus 1. Now x plus 1 to the third. All right, that means x plus 1 times x plus 1 times x plus 1. All right, again, that doesn't mean x to the third plus 1 to the third. It means each of these times each of these. So if I multiply, now don't try to distribute that x to everything. If you multiply the first two, we did that already. We got x squared plus 2x plus 1. And then multiply that times x plus 1 by this one. So multiply each by each. So x squared times x is going to be x to the third. And then x squared times 1, that's going to be plus x squared. And then 2x times x is going to be plus 2x squared. 2x times 1 is going to be plus 2x. 1 times x is going to be plus x. 1 times 1 is plus 1. Are there any like terms? Yes, there are. All right, so this is going to come out to equal x to the third plus 3x squared. And then combine those plus 3x plus 1. So the next problem you could see is x plus 1 to the 4th power. All right, if I kept working it like this way, it would take a long time because I did all that and then I had to multiply all this times x plus 1. Surely there is a shorter way to do these problems. And the answer is yes, there is. All right, but in order to figure out the shortcut, there's something I need to show you that at first looks like it has nothing to do with these problems, but once you see the pattern, it'll have everything to do with these problems. This is called Pascal's Triangle. Pascal with a P, Pascal's Triangle. All right, it's a number pattern. It starts with a 1, and then 2 1s, and then 1 2 1 is the next row, and then 1 3 3 1, and then the next row would be 1 4 6 4 1. You see in the pattern yet? Well, let me show you. The next row would be 1 5 10 10 5 1. Do you see the pattern yet? The pattern is each number that I'm writing is the two numbers above it added together. Like here, 1 plus 1 gives me 2. There's a 1 on the end every time. 1 plus 2 will give me 3, 2 plus 1 gives me 3, and then this one, 1 plus 3 gives me 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. So what would be the next row? I'd have a 1 on the end. 1 plus 5 give me 6, 5 plus 10 would be 15, 10 plus 10 would be 20, 10 plus 5 would be 15, 5 plus 6 would be 1, and then you'd have a 1 on the end. All right, that's Pascal's triangle. Now it keeps going on and on forever. These are the main ones we're using. Now, why am I showing you this? What on earth does this have to do with expanding binomials? Well, if you look at the answers we got. Look at the numbers of the answers that we got. All right, remember there's a 1 in front of the x if they don't put a number right there. So what do you notice about the numbers in each of these answers? They match up with the triangle. X plus 1, we got 1 and 1. When it was squared, it was 1 2 1. Right here when it was third, 1 3 3 1. So basically looking at that pattern, x plus 1 to the 4th power, just looking at this triangle, what should the answer be? It should be 1x to the 4th, so x to the 4th, plus 4x to the 3rd, plus, and the next number would be 6x squared, plus 4x plus 1. All right, getting that from the triangle. That would be my answers to this problem. X plus 1 to the 4th power. All right, that's the same answer you get if you took all this stuff and you multiplied it by another x plus 1. All right, so this Pascal's triangle, it's a shortcut. It is a quick way of expanding these binomials. That's why it's called the binomial theorem. right? It's the theorem that lets you do this. All right, so if you can use this triangle, do I have to memorize the triangle? You have to know how to make the triangle. All right, once you've made the triangle, then you can actually just use the numbers in the problem. So let's look at, again, how do you apply this, especially when it's not just ones, because most of the time you're not going to have a 1 right there. So if you look at problem number 5, x plus 2 to the 5th power. Now, I want to expand it. I'm using the 5th power, so I want to use the row that has the 5 in it. I want to use this one right here. So I'm just going to write the numbers, leave some space. I'm going to have 1, 5, 10, 10, 5, 1. Let's just put pluses on each of those. Oops, make sure I'm on the screen. All right, so I got those numbers from my triangle. Now, you notice in all these answers, they all start with x to the, where'd this exponent come from? How could I get the exponent in each of these answers from the problem? It's that one, right? So this one would have x to the 5th. And then look at the answers that we got for all of these. What's happening to the exponents? It's going down. It's getting one smaller. This one's x to the 5th. This one have x to the 4th. This would have x to the 3rd. The next one would have x squared, and then x to the 1, and then no x at all. It'd be like x to the 0. Now, not only are the x's descending, the number right here, it's the opposite of that. All right, so 2 to the 5th would go right here on the end, whatever this is. Now, these were 1s. 1 to the 4th, 1 to the 3rd, that didn't do anything. But here I have a 2. So I'm going to have 2 to the 5th on the end right here, then 2 to the 4th, then 2 to the 3rd, 2 to the 2nd, 2 to the 1, and then no 2 at all. Now, what did I just do? I did the same thing I did with the x's. I did it with the 2. It's just opposite order. The last one's going to have that number to the 5th, and then that number to the 4th, that number to the 3rd. So I'd have to actually work this out. So my final answer, I get x to the 5th here, plus 5 times 2, that'd be plus 10 x to the 4th. And then, now do exponents before you multiply. 2 squared, that's 4. 4 times 10, I get 40, plus 40 x to the 3rd. And then 2 to the 3rd, that's 8 times 10, be plus 80 x squared. And then 2 to the 4th, that's 16. 16 times 5, that's 80. All right, and then 80x. And then my last one, what's 2 to the 5th? 32. All right, so that whole thing would be my answer. This is much quicker than trying to multiply x plus 2 times x plus 2, and then multiply that answer times x plus 2, then that answer times x plus 2, then that answer times x plus 2. It saves you a lot of time. Okay, now, next problem. It's almost the same thing. It's an x minus 2 to the 5th. So how do you think that minus will affect this answer? All right, some people might be thinking, well, it's going to make everything negative. Or some people might be thinking, well, it's not going to change anything. Well, let's look at this. All right, if I'm following the same pattern, so again, it's 5th power, so I'm going to use my row with the 5s. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. And yes, I know it's a minus right there, but I'm going to put pluses for now. We'll use that negative in just a minute. All right, so again, this one, I'm going to start with x to the 5th, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, oops, x to the 2nd, x to the 1, and then no x on that one. Now this time, my last number, it's not just a 2, it's a negative 2. So here at the end, this would be negative 2. Negative 2 to the 5th. And this one would be negative 2 to the 4th. Negative 2 to the 3rd. Negative 2 to the 2nd. Negative 2 to the 1. And then no negative 2 on that. So let's see what that does to our answer. This first one would still be x to the 5th. That looks the same. What's 5 times negative 2? It can be negative 10 x to the 4th. Now negative 2 squared, is that positive 4 or negative 4? That's positive 4, negative times negative. Times 10, I get plus 40 x to the 3rd. And then negative 2 to the 3rd. Is that going to be negative 8 or positive 8? It's going to be a negative. Negative times negative is a positive times another negative is a negative. Negative 8 times 10, I'm going to get negative 80 x squared. And then negative 2 to the 4th, that's going to be a positive. Positive 16 times 5, going to be a plus 80x. And then negative 2 to the 5th, That's going to be a negative. And negative to an odd power gives you a negative. Negative to an even power gives you a positive. So negative 32. So look at our answer. How did having the minus in the problem affect the answer? It made every other term negative. All right, it didn't make them all negative, just every other term. Basically the ones that had the odd exponents, when I worked that out on the negative 2, they became negative. All right, so 3 other quick examples I want to look at. What happens if you have a number on the x? So 2x minus 3, it's to the 4th power. So let's use our rows with the 4. All right, 1, 4, 6, 4, and 1. Let's just put our pluses, even though, yes, there's a minus there. We're just going to use that as a negative. We'll put pluses for now. All right, so my first one is not just an x this time. What am I putting on this? 2x to the 4th. Put that whole 2x in parentheses. 2x to the 4th power. Then 2x to the 3rd power. 2x to the 2nd power. 2x to the 1st power, and then no 2x. And now same thing. Now this time my back number is not just a 3, it's a negative 3. So this one's going to have negative 3 to the 4th, negative 3 to the 3rd, negative 3 to the 2nd, negative 3 to the 1, and then no negative 3. So now this time, that 4 exponent, does that apply to the 2 or to the x? It applies to both of them. All right, I'm going to have to do 2 to the 4th, which is 16. All right, so I'm going to get 16 and then x to the 4th. And then over here, 2 to the 3rd, that's 8. I'm getting 4 times 8 times negative 3. So 32 times negative 3 is going to give me negative 96. X to the what power? To the 3rd. All right, now over here, I'm going to have 6 times 2 squared times negative 3 squared. So 2 squared, that's 4. Negative 3 squared, that's positive 9. So I'm getting 6 times 4 times 9, which is going to give me a big number. It's going to be 216. Positive 216 x to the 2nd. And then the next term, I've got negative 3 to the 3rd, which is, what is that? That's negative 27. So I'm getting 4 times 2 times negative 27, which is going to give me negative 216, just an x. And then negative 3 to the 4th. Is that going to be positive or negative? That's going to be positive 81. Basically, one thing you could do whenever there's a minus in the problem, just check to make sure your final answer, it should alternate between positives and negatives. You shouldn't have 2 negatives or 2 positives side by side when there's a minus right here. All right, 2 other quick ones. This one, x and y, looks harder, but actually this one's pretty easy. All right, it's to the 4th power, so let's use our 4th row. 1, 4, 6, 4, and 1. So that's going to be x to the 4th. Ooh, let me put my pluses. X to the 4th, x to the 3rd, x to the 2nd, x to the 1, no x. And then same thing with the y's. Y to the 4th at the end, y to the 3rd, y to the 2nd, y, and then no y. Is there anything to combine? No, there isn't. That's the answer. So if it's just variables, there's nothing to work out. Now this last one. This one's going to be a little tricky. What if we have exponents inside of this? Okay, so it's to the 3rd power, so we're using our row with the 3's. This one will be a little shorter, all right, because it's going to be just 1, 3, 3, and 1. Let me put my pluses. This time, it's not just an x right here. It's x squared. This whole x squared, x squared is being raised to the 3rd power. And then this one's going to have x squared to the 2nd power, and then x squared to the 1 power, and then no x squared. And then in the back right here is not just a y. What do I have right here? I have a whole 2y to the 4th. So this whole thing, this whole 2y to the 4th to the 3rd power, then 2y to the 4th to the 2nd power, 2y to the 4th to the 1st power, and then no 2y to the 4th. Okay, so to work this one out, well, no, it's getting long, but we're almost done. Power to power. What should I do with this 2 and this 3 exponent? I should multiply it. So that's going to become x to the 6th plus, now we've got 3, this 2 exponent just goes to this exponent. This 2 doesn't have an exponent outside. This 4 exponent just goes to the y. So I'm left with just 3 times 2, which is 6. I'm going to x to the what power right here? To the 4th. And then I have this y to the 4th. And then the next term plus, let's see, I have a 3, I have a 2, and that 2 is being squared. So 2 squared going to be 4. 4 times 3 going to be plus 12. And then x to the what power? X squared, and then y to the 4th, but it's getting that squared also. So multiply those, going to be y to the 8th. And then the last term plus, I've got a 1 times 2 to the 3rd. What's 2 to the 3rd? That's 8. Plus 8 y to the, not to the 3rd power, not to the 4th power, going to be what? Going to be to the 12th power. 4 times 3. Power to power, you multiply those. So there it is. That's expanding binomials using Pascal's triangle. Hope that was helpful. Hotard out.